Hello Commander 16 fans and supporters. It's been a while since I've done an update of the Commander 16 Assembly Language Environment. I've been working really hard to get the interactive editing of labels and interactive editing of instructions added to the program. Before we look at the new features, let's take a step back and look at the design goals that David has set forth. Back when David and I first started talking about the monitor for the Commander 16, he referred to it as a super monitor. What I finally realized he was talking about was something that was effectively an integrated development environment for writing assembly language programs, much like BASIC is on Commodore or the Commander 16. Of course, the system is going to let you view and set memory, either blocks or specific locations, and then format it as bytes, words, strings, etc. You can look at your disassembled code, but more importantly, David wanted support for not only the instructions, but having labels on them. Any experienced assembly language programmer is going to tell you labels are very useful instead of dealing with raw hexadecimal addresses and values. He went a step further and said you should be able to enter new instructions. Effectively, this is a single line assembler. And of course, we want to be able to run the program, set breakpoints, and look at variables. Finally, save and restore. Up till now, as I've been developing, I've been doing, much like everyone else, work with the emulator. And I've got my host computer, which in this case is an Apple Macintosh OS X based machine. And I've got my emulated Commander 16. Over on my host, I'll edit my assembly language program, in this case, example. And then I assemble it. I'm using the Acme assembler. And then I prepare it for loading into the X16 using a Python script I've written called CLC, the Commander Label Compiler. This takes all of the label and symbol values that are generated by the Acme assembler and loads them into a debug formatted file that the assembly environment is going to be able to read on the X16. And then copy all of my files over to the X16 and start up the assembly language environment, and then I can proceed to work on my program. Of course, this is all automated using a make script on the OS X host. Eventually, we want to be able to get to the point where we can do everything locally on the X16 and not rely on any host work at all. Once I've actually built my example program, now it's time to actually look at it. So the first thing I'm going to do is I will load the assembly environment and then give it a run. Up the top, I've got the menu of operations that I intend to use, and those are all operated using the function keys. And then in the middle is where we're going to see all of our information. First thing is to, using F1, I'm going to load my example program. And in this case, I'm just going to type the name of the executable code that gets loaded. And then the assembly environment will infer the name of the debug file and then load that secondarily. In this case, it would be example.debug. The assembly environment's loaded both, and we're ready to go. I'm going to back out, and using F3, go into assembly mode. I'm going to take a look at my code. This particular example program I had assembled at A1000 to stay out of the way of my program, and there it is. So it completely disassembled this code from the binary and picked up the label information out of the debug file and is showing it at the correct place. So I can go down and I can look at different operations and things like that. So now the assembly language environment is showing my example program. It's got all of the same instructions that I originally wrote, but of course it disassembled them from binary. And it picked up all of the labels that were defined and prepackaged with the CLC program I mentioned earlier. So a label being defined at a particular spot, for example, the entry point at A1000 has a label example main, and you'll see that in green. Or the example loop at A015 is defined in green, but you can see it being used at A017 where it does a branch equal. Now that I've validated that the code is exactly what I had written, I'm going to go ahead and run it. I'll back out of here and choose F4 run, start it at A1000, and the program then runs to completion. In this case, it changed output to 40 by 30 character mode, output some strings, and return control to the assembly environment. The assembly environment holds the user screen so I can see what my program did until I'm done, and then any key, and I'm back into the program. But usually when I'm writing a program, something isn't going to go right. And so to do that, I need to set breakpoints, and I need to look at some data variables and things like that. In this case, I'm going to set a breakpoint down at A025, where I've got a series of load A, X, and Y instructions, just so I can demonstrate the breakpoint. And it loads successively a hex value of 42, 43, and 44 into the A, X, and Y registers respectively. So setting my break at A025, I am ready to go. I'm going to run the program again. F4 A000. Program runs, and now I'm broken at A025. If I use F5 to step over the instruction, in this case, I will be executing the instruction load 42 into A. We'll see what happens. And now, if you look in the box in the upper right hand corner, you'll see that A contains the 42. Let me single step again. And now X has got the 43, and we should see Y, which right now has a 4D in it, should load 44. And in fact, it did. So I'll just continue to completion, and the program runs. Usually when I'm running a program, you also need to look at some variables. And that's the watch functionality that's included. If I back out to the top level and pick watch, I'm able to choose if I'm looking at a byte, a word, in either a C string or a P string. In this case, I'm going to take a look at a word that I have at A0E4. And you can see that it adds it over into my watch locations. I can add several watch locations, and those will update. Every time I hit a breakpoint, I'll see what the latest values are. And then finally, let's go to the View menu, F2, show you the symbols. But here are all of the symbols that were defined by my assembly language program. And then there's my watch variable, A0E4, example main, right here at A0000, which is where my program starts. Now I'd like to show you the new functionality that's available in 0.6. You see that the example program still has all of the labels that were originally included in the assembly language program. With 0.6, we have the ability to change, edit, and remove labels. If, for instance, I decide that the example loop is not a very descriptive label, I can scroll down and I can remove that label using F6. And then I can go ahead and put in a label using F5, and I might say, I'm going to call that one print loop. You notice nothing's changed in the code. The jumps and the branches are still targeting exactly the same thing because we haven't modified the original binary. The only thing that we've changed is how the code is interpreted by the assembly language environment. Also, down there where it says example done, you may recall I had some useless load A, load X, and load Y instructions in there to show off what was happening during the breaks. While I'm a fan of useless code, maybe I'm not a fan of that useless code. I can now delete some instructions, and using F3, I'm going to delete those 3 instructions. But as I said, being a fan of useless code, I really want something truly useless, so I'm going to put in some no operations. And using F2, I can then use the inline assembler and insert a couple of nops. And I think 2 is probably enough uselessness. But then, of course, I also need to have a loop label down there, an exit label. So using my functionality with F6, I'm going to add the label, and I'll just call this one done. And if you notice, the instruction, the branch equal at A017 is now referring to the new label. Now there are some limitations with editing of instructions. I currently do not relocate code. If, for instance, I modified something in the loop and added some more instructions, the relative offsets would not be recalculated and the code wouldn't work. If you're loading an address value, which we currently have to break up because of the 8-bit nature of the processor, the assembly environment doesn't know how to go back in and fix that code. That will also be coming in version 0.7. So now that version 0.6 is out, where to from here? Almost immediately I've got to produce a version 0.61. Since emulator version 35 was just released as I was preparing this release. The next major release must have the code relocation so that you can enter instructions and everything will continue to work as you expect it to. We need to add some feedback information about where the breakpoints are, and of course support other drives as well as save. With version 0.8, we'll preload the kernel calls into a new program, and a major work effort will be to refactor the code so that it is ROMable. And then with version 0.9, that would be our beta test where all the functionality should be complete. We're just looking to close out bugs. And finally 1.0 will have it in the ROM and shipping with the units. Finally, if you find any bugs or you have some comments, please send me an email at x16.asm.env@gmail.com. If you haven't done so already, you can read more about this particular release as well as download the program itself from the site URL on the screen. I'm not going to bother repeating that one. Thanks a lot for watching. Have fun.